Hi folks, this is the first video in Unit 9, Packet 1. So this video is actually just going to be on the geometry formulas reference sheet because I want to go over the names of these shapes, many of which we are familiar with, some of them which are new, and then we'll talk about just a few properties of each so that you are familiar with them when you see them come across on this unit. Now this video is for honors and regular geometry as well. Those of you who are in honors will have to complete the full 3 packets. Those of you who are in regular geometry, I've condensed the 3 packets into 1 packet, and that's all you'll have to complete before you both take your tests. Okay? All right, so let's get started. Our first shape here is our tried and true triangle. It would be beneficial for you guys to write these as I move along as well. You'll notice that this is a triangle that has an altitude. I see a 90-degree here. There's no degree measures, but B here stands for the base and H stands for the height. You'll see that come up a lot. Next shape is a square. I know this is a square because both 2 of my sides here are the same, so S stands for the side here. They didn't use the notation, but I want you to put the notation yourself, and you'll also notice that each one of these corners is 90 degrees, and that fulfills the properties of a square. Next one is a rectangle, a little different than a square because my length here is going to be a different value than my width. But similarly to a square, I do have 90 degrees on each corner. Okay. For a circle, which you just got done with that unit, the 2 components that are super important here are understanding the diameter runs through the center point from end to end of the circle, and the radius runs from the middle to the end point of a circle. So again, you'll see the terms R and D, R for radius, D diameter, and C stands for the circumference. But that shouldn't be any new stuff. We just did that. Okay, moving on to the next shape. Back from Unit 5, we see parallelograms re-enter the chat. So with parallelograms, you'll notice that they did break up this shape in a triangle on the flank side, on the left side. And then it's again, if you were to draw the same type of triangle, it would be flanked on the right side. These are actually the same triangle. They should be the same triangle. But in terms of knowing these components, you have your bottom side here known as the base, and the height is within. It's inside the shape. So it goes from the top to the bottom value. You might also see height placed like this. It's fine as long as you know it's going from the top to the bottom. And then we have an irregular trapezoid. So in this case, the height and the base are labeled separately. So in this case, in this previous parallelogram, this base on top, let me erase this so that it's less confusing to see what I'm talking about. The base on top and the base on the bottom are the same. They are congruent, so they both are B and B. However, in this trapezoid, the base on top is a different length than the base on the bottom. Therefore, we have to differentiate base 1 and base 2. Height remains the same. It's from the topmost point to the bottommost, creating that 90-degree angle. So when you start getting the area for parallelograms, you'll have to use both the base values. Okay, next up we have a rectangular prism. Okay, a prism is a very simple type of shape. It's a 3D shape. It has to be. Prisms are 3Ds, and this is where we get those 3 dimensions. Length is a dimension, width is a dimension, and height is a dimension, all which are needed to find the volume. And if you don't remember, volume is the space inside a 3D figure, like all that space inside. Think of a pool or even a glass of water has volume because it has space to hold inside. Surface area, however, is only the area of a face of a shape, right? So if I wanted to find the surface area, just the area of this face, I could just calculate length times width, right? But if I wanted to know the surface area of the entire shape, I would still need all three of these dimensions and use them properly, which we'll do examples of. Okay, and then next up we have a triangular prism, and there's that word prism again. Prism is a particular 3D shape because the base is going to be the same as the top, right? A prism is basically just that shape on the base, and you're just connecting it to the same shape on the top. That's what discerns it from like a pyramid. Anyway, so here we have notice that this is a capital B and the previous ones were lowercase b, right? Let's see if we had another one with base. Yeah, lowercase b. Capital B stands for area of the base, right? That's why they've shaded this part down here in gray, telling you that that is the area. So in order to find the volume of this triangular prism, you have to multiply the area of the base with the height of that prism. LA is just the surface area of one of the faces, and SA is the surface area of the entire thing. All right. Next up, this one is a square. Actually, I'm not going to say that it is a square because I don't know if it is, but this is a quadrilateral pyramid. And the reason it's quadrilateral is because the base is a quadrilateral base. Now, if the base was a triangle, this would be called a triangular pyramid. If the base was a hexagon, it would be called a hexagonal pyramid. Again, we see this capital B, which means the area of the base. And then we also have this component here, the length. But I do believe that this is the slant, the length of the slant. So that has to be discerned properly. The height talks about from the topmost, the apex, all the way down to the base, creating that 90-degree angle. Okay. Next, we have a cylinder. Very simple. Your bases are the two same circles. They have to be equivalent or congruent, sorry. You will need a radius and a height to find the volume surface area of this shape. Next, we have a cone. Again, it's a base of a circle, but what's different from a cylinder is that instead of having a circle on top as well, we just connect the sides into a point. Again, the height is from the topmost apex down, creating that 90-degree angle, and then the radius is from the circle out to the edge. Oh, look at this one. This one's everyone's favorite. I said sarcastically. Pythagorean. I don't know. For me, even if I don't use Pythagorean theorem, like I see a right triangle, I'm immediately like Pythagorean theorem. Anyway, it is Pythagorean. So a squared plus b squared equals c squared. Please make sure that you know that c is opposite the 90-degree, and also c has to be the largest value. All right, almost there. Okay, next up we have a sphere. Such a famous shape that Vegas decided to create a big old theater after it. So a sphere is just a 3D circle, so to speak. You just take that radius. It's most important here. Pi comes included with the instructions. Next up is we have half sphere. I know, super complicated. Again, all you're really concerned with knowing here is the radius. All right, and then last but not least, we have the arc degree or measure, right, within a circle. So this area stands for the area of the shaded region. So area of that arc, so to speak. And this should look familiar to us as well. All right, so that's it for this video. The next video, I will start moving in with examples of this work, and it's really not that complicated. And please keep in mind that you will be able to have your notes for your test, so do take complete notes. All right, I'll see you in the next one. Bye.